Hi, welcome to another episode of The Art of Physics. I'm Art Wiggins, and I'm here today with, not quite live, but I have to do this. I promised this fellow, do you see this fellow on the other camera? I promised him that I would take good care of him and give some of the details of his fabulous contributions to science. And I haven't done that quite to the level that he would like yet, so I have to go a little bit further. So let me tell you about a particular year in his lifetime, and that year was 1905. Because in 1905, it is referred to as the Annus Mirabilis. And Annus Mirabilis is the year in which he had many papers published, and these were fabulous papers. Here's a better picture of him. This is one that I actually had a little talk with the artist about. This one is, Einstein is shown as an older fellow, but the artist was trying to portray the feelings Einstein must have been feeling in 1905 as he arrived at this Annus Mirabilis and had so many things going on all in the same year. In that same year, there were 5 papers that are published, and this is the Annalen der Physik. And these papers, 4 were in 1905, the last one was in 1906. And in March, he published a paper that introduced the quantum and really led to, it enhanced the development of quantum mechanics in great order. And also it had to do with something about the photoelectric effect, which we're going to see a lot more of today before the day is over, but I'm saving that for a little bit later. That was March 1905. April 1905 was his dissertation, and so that's how he got his PhD in 1905. And this was a dissertation about, of all things, Avogadro's number. If anybody's ever studied chemistry, they know what Avogadro's number is: 6.02 times 10 to the 23rd molecules in a mole. Well, that's terrific. Einstein came up with a theoretical justification for this in an unusual way, which actually was pretty doggone good. It was even better when he found later a slight mistake in the dissertation, and it made it even closer than the original thought was. That was April. Then May, he published a paper in the same Annalen der Physik, and this paper had to do with what's called Brownian motion. Anybody who's ever looked through a microscope and seen, when you get down to the level, the lowest possible level of anything you can see under the microscope, and you're looking at something in this microscope in great detail, and you're seeing, and the thing is kind of moving around a little bit. And you think, is this a nervous little critter that's moving, or what exactly? Not necessarily. What happens is what's called Brownian motion, because I think Brown was the first one to notice this. What happens is that the molecule, I should say, whatever the object is you're looking at, that may be just slightly larger than molecular size, moves around, and it moves around because it's being hit by molecules. And so this is the kinetic theory that says that molecules are in motion, and the motion of molecules bangs into things and will knock them around. Well, Einstein got this in 1905, published a wonderful paper about it. That was May. Then June, he published a paper about special relativity. Special relativity, oh my gosh. This one was just amazingly revolutionary, because special relativity says that it isn't time and space that are absolute. It is instead, what's absolute is the speed of light. The speed of light is absolute, and time and space are relative. This is a revolutionary idea, and is carried through in so many interesting ways and generated all manner of technology in the modern sense. And this all came from this paper in 1905. Actually, there are 2 papers. He had a second paper in 1905 that was a supplement to that first paper about relativity. This came out in September. So March through September, he has all these papers published in his dissertation and so forth. It's terrific. There's one more thing that happened in 1905 to Albert Einstein that you need to see. And so we have a graphic of this one. Let's see what this one is about. Yes, this is his son, Hans Albert. And this was Albert himself and his son in 1905. And they look like pretty happy campers, don't they? Yeah, you know, you got a baby, and this was a very good baby. He was just delightful to be with. So 1905, the year of miracles for Albert Einstein. No question about that. So you may wonder, about what it is that sets up a miraculous year, in which in 6 months, this one fellow does all these things. Part of the answer to that lies in the fact that he had some friends and some buddies that helped him out. This graphic that you're seeing now is something that's called the Olympian Academy. And the Olympian Academy are his two buddies, Maurice Salavine and the other one, oh my gosh, the name has escaped me, but these buddies got together and they talked over things that were at the root of the scientific world at that time. Conrad Habicht is the other guy. So they talked over these things and figured them out in so many ways. And there's a famous quote from Einstein here that says, "I soon learned to scent out what was to lead to fundamentals and turn aside from everything else, from the multitude of things that clutter up the mind." So now you may wonder, how did Albert Einstein manage to get a little time to get together with his buddies to talk about these big ideas? And the answer was, he was underemployed prior to 1905. That is, until 1902, he didn't have a job. And so he had more time to talk to his buddies and think about things he did, and in good order. What happened then in 1902 was he got a job in the patent office. Now, the patent office was not something of a fundamental scientific nature. The patent office had to do with examining the ideas of a bunch of Swiss inventors that wanted to invent fascinating things. And of course, Albert Einstein could think his way through a lot of things very nicely and still have a little time left over to think about the big ideas of physics, which he kept in his center desk drawer. And one might wonder if they had little work cams that could spy on people and know how much time he spent looking at the items in his center desk drawer. And I'm sorry, I don't mean to offend you, Albert. I know he gets sensitive about those things if I bring on too much of a problem. So I take it all back. I'm sure that you did everything you needed to do. So we'll just stipulate that. And I do want to talk a little bit about some of the thought process that he underwent. I don't think this will offend him. It's actually a two-step process. Here's another quote. "I rarely think in words at all. A thought comes, and I may try to express it in words afterwards." So Einstein thinks about things and has internal visualizations and doesn't think in words, doesn't think in symbols, and so he thinks about pictures, abstract things. But then, of course, he has to translate that into something that he can communicate to other people. How does he do that? According to him, he uses what's called a sounding board. And what does a sounding board consist of? Well, we have another graphic for that. Here is the fellow Michelangelo Besso, shown with his wife, Anna Winteler, who actually Einstein thought was the best sounding board in Europe. He got a job for Michelangelo Besso in the patent office. And the two of them lived nearby, walked to and from work each day, going to the patent office, coming back home, talking about, in many cases, the big ideas of physics. And so from Einstein's viewpoint, he says that Michelangelo Besso is the best sounding board in Europe. So these ideas that are going through Einstein's mind, he expresses in words to Michelangelo Besso. And Michelangelo Besso listens, maybe makes a few suggestions along the way, but when people talk to Michelangelo Besso and say, "Oh, so then you really helped out Albert Einstein in his development of special relativity and the quantum," he says, "No, I listened and maybe made a few suggestions along the way, but that's about it." And so from Michelangelo Besso's standpoint, he didn't do much at all. Guess what? A sounding board is exactly what Albert Einstein needed. He needed to bounce these ideas off somebody. You know, we all have sounding boards in one form or another. I think when we're really making good progress with things, we're talking to other people. And as we talk, we formulate ideas in ways that are understandable, not only to these other people, but to us. That is, we're translating some pictures from our own mind into words, and those pictures into words help us enormously to carry out a lot of the things that we do. So the results that Albert Einstein had in 1905 were spectacular. I mean, absolutely spectacular. One of them was special relativity. And we all know that special relativity has just changed a lot of things about the way the world works, especially in terms of the technology. Besides that, there was a lot of ferment going on at the time about whether atoms were real or whether they weren't real. There was the ferment about the quantum that Max Planck had thought up as a mathematical gadget to try to solve a problem with the radiation from heated bodies. And Einstein took it seriously and said, okay, suppose that is the way it is. And if that is the way it is, then Einstein took it seriously and said, that explains a number of things, one of which is called the photoelectric effect. So then that's what we're going to really be about today. So watch this very carefully. We have a diagram here, and the diagram shows what happens is that for particular materials, if light impinges on these metals, then an electron jumps off. It takes light of a particular frequency to make this happen, of course, and so that's unusual, and this frequency had a lot to do with exactly what the photoelectric effect was all about. This was one where he won the Nobel Prize, in fact, for the photoelectric effect. So, okay, now, so far it sounds like a lot of theoretical physics, right? Yeah, pretty theoretical, you bet. But guess what? There are whole industries that have been made based on these ideas, one of which is the photoelectric effect. Suppose that you could get light to shine on the metal and the electron to jump off. Now suppose you get that electron to jump off into a wire, and then suppose you could run that wire through and make a circuit out of this, and then you could have an electric circuit, and oh my gosh, so what would do this? Can you imagine anything in modern technology that involves light causing an electric circuit to work? Yeah, there's the photoelectric effect in big order when you have solar panels. And so the biggest deal about solar panels is the same big deal that got Albert Einstein the Nobel Prize in 1905. So here's what we're going to do. We're going to find out about solar panels and about how solar panels really work in the modern world. And to do that, we need to take a field trip. And we're going to take a field trip to a place that has installed some solar panels that you can't believe. This is a field trip to a place called 1-800-Law Firm. And we're going to go there, look at their solar panels and various other things that they're going to show us along the way. So come along for this field trip. We'll see what we can dig up. I promised you a field trip. And sure enough, we are in the Albert Einstein conference room at 1-800-Law Firm. And as Albert Einstein said, imagination is far more important than knowledge. So we're here to talk about some imagination. And with us is Ari Kresch. He is the CEO of 1-800-Law Firm, the firm which has this building and which has done some fabulous things with Einstein's imagination. Einstein's imagination had to do, of course, with the photoelectric effect. So how do you use the photoelectric effect, Ari? What are you doing?
We're trying to make a light footprint on the planet. We're trying to generate electricity using the knowledge that we obtained from the Nobel Prize that Albert Einstein won.
Wonderful. So then what happens is the sunlight comes down, hits your solar panels, and then electrons jump off, and you persuade them to go into wires and do all
sorts. That's exactly right.
Wow.
We have them funneled right into the wires.
Man, you're very persuasive.
Well, we're using the laws of physics that I learned from my former physics professor.
Really?
Yeah.
Where would that be anyway?
I have no idea.
Oh
but,
my gosh. Well, that may have been a couple of years ago, but I think physics probably still applies, doesn't it?
Same rules apply.
Yeah, wow. So what you've done is you have solar panels. Now, are they just on the roof, or do you have them elsewhere besides?
We've got them on the roof. We also have them on a carport that has charging stations for cars. I'm going to take you up onto the roof. You're going to climb up the ladder. You'll be able to see not only the solar panels, but you'll be able to see 4 wind turbines that are capable of generating electricity using other principles of physics.
Oh my gosh. So this is the 1-800-Physics building.
Pretty much.
Almost.
Yeah, yeah.
Wow. That is really neat. So Well, let's see then. You're doing this as a way of making a light footprint on the planet. I noticed, and you guys may have noticed the cameraman too, as we walked in, it was dark in here. I say dark, not so dark you couldn't see, but it wasn't a really bright light that actually uses up an awful lot of electrical juice.
Yeah.
And so you do that, don't you? Because
We do that. We've got a lot of photo sensors in the building, and also we noticed that people like working in an environment that doesn't have bright fluorescent lights. If you walk into the rest of the office, you'll see that we have skylights that help with reducing the consumption of electricity, and you'll also see that we have floor-to-ceiling windows that bring in as much light as we possibly can.
I noticed that. I looked at the other conference rooms that you had around here, and I noticed that there were just, it's huge window area. That's just terrific. I mean,
Why not?
yeah,
It
exactly.
really feels better working next to a giant window.
Yeah, exactly right. Well, that makes it very interesting. So with all of these solar panels and wind turbines, then how much do you really generate? You had some notes on that.
Oh,
What
I
was
did.
What was that all about?
I can't remember that.
Oh,
so
that's
well.
okay. You don't have to
But
remember.
we actually are officially becoming a utility
Whoa.
because we don't store the energy in batteries. Anything that we produce that we don't use, we just sell it back to the grid. And our system is regulated by law, so we are doing the maximum we're allowed to do, which is 150 kilowatts. We produce 144 kilowatts of electricity through the solar panels, and we have 4 wind turbines up there capable of producing 6 kilowatts. Wow. On an annual basis, we will produce 183,385 kilowatt hours using the solar panels and over 10,000 kilowatts of power from the wind turbines.
That's amazing. Now, what fraction of your total energy consumption does that represent?
I'm told 50%
Wow. So you get 50% of your energy from natural sources.
from natural sources.
Wow.
And Art, I have to tell you, part of the reason that I was inspired to do this is because we are right on the corner of Lazar and 696 and Northwestern.
Oh,
Hundreds of thousands of cars pass by our building every single day, and I want to inspire others to do similar kinds of things.
oh, you're in a good position for doing that. My gosh. I guess the other thing I was thinking was that you could probably hire a bunch of college professors to talk, and that would probably generate quite a lot of wind for your wind turbines.
I like it.
So, yeah, well, it could
Yeah.
work. I mean,
Well, hot air is more efficient in pushing around the turbines.
I think you're right. Well, it's interesting, you know, every time I have a guest, I like to Google them to find out what they're all about. So David is going to insert into this a picture of you that I found by Googling. And so there's a picture, and I thought,
Is it
wow.
a baby picture?
No, it actually looks fairly recent. And I thought, I think that's that good-looking guy. I think that's him. And so then I thought, well, maybe I can get another one. So I went even further and Googled you again, and I found up came a picture of Lady Gaga. And I was beginning to wonder if you had some additional workings that I was unaware of.
No, that's sometimes I parade around at night, you know.
That's what I wondered. I had to try to find that out.
No, we're involved in consumer protection litigation, and we had an issue once upon a time with some fundraising that she was doing. So
I see. So, well, I guess that explains it. And of course, attorney-client privilege prevents him from telling us many more details about Lady Gaga. And I'm not sure that this Bloomfield Community TV is ready for it anyway. So maybe we'll just let that one rest. And be happy to find out about the energy consumption and the utilization that you guys are doing. I mean, it's phenomenal. And you are making a very good example for everybody else.
thank you.
So I think David is going to cut in some good pictures that he's going to take as we climb the ladder to success
Yeah.
of the solar panels, the wind turbines, and whatever else he can find, short of Lady Gaga, who's, I understand, not in the building anymore. So he'll cut those in and make those really work. And
Don't forget, David, to get a shot of Art climbing the ladder.
From the back or the front? Would be better.
His choice.
His choice, okay. It works better that way. He does that so confidently. I like it. Hello. Now what? It looks terrific. And you've aimed this so the solar panels are at a good angle that will take advantage of the sun, angle very nicely, but you don't want to move them. See, there are steerable solar panels too. Active solar panels that track the sun.
I've heard that. I've heard that.
What a great view. I love it. This is just beautiful. So now the solar panels take the sunlight coming from generally that direction, south, and these panels have in them sensitive metals which have electrons that pop off, and then you've persuaded them to go into these wires that are throughout this whole area up here and shoot on down to actually power your building.
You want to hear a very amazing thing is that each of these panels will be monitored off-site through the internet, so they can tell me if I got a bad panel.
Oh my gosh, every panel.
Yep.
There are probably 300 panels here, is that true? I'm guessing.
There's 550
Including the
carport.
parking lot, wow. So probably 300 on the roof. These babies, the turbines are going to generate additional energy by turning. They probably generate electricity, true, and the electricity goes through those other.
They actually generate propane. We got propane there.
No, it's cows that generate. That's methane anyway.
Oh, methane.
Chemistry was never my favorite. Oh, geez. Well, this is really neat. And the visibility, as you say, as I was saying, look at all the view you can see. Well, guess what? That same view sees you.
And this is, the skylights that we have.
Yeah. So those go down the center. That's the core of the building.
They don't go down the whole core. They just go to the 4th floor.
Where you happen to have your offices. Right. Sounds right. Well, this is excellent. It's really excellent.
Hardest part.
I think now it's easy. That's what they said to Wilbur and Orville too. It's easy from here.
Exactly.
And sure enough, it is.
Thank you very much, and see you next time.
Well, I want to thank you an awful lot.
Thank you. It's a pleasure.
Enjoyed this.
Always.
It's just a huge pleasure for me. I hope it's been a pleasure for the rest of the people who are viewing. And so have a great time. And I'm Art Wiggins, and I'll see you again if we're lucky.